Dear audience, how many of you have ever had a CT scan or an X-ray done? Almost everybody. And how many of you have ever wondered where the nuclear waste from the treatment goes? Very few. Controlled exposure to radioactivity can be beneficial, like in these medical purposes. However, unintentional exposure to radioactivity can be harmful for humans and the environment. Radioactivity does not only come from medical purposes. Most of radioactivity comes from the nuclear energy industry. Mined from radioactive uranium, fusion and fission reactions are powered on atomic scale. And they produce and generate a lot of radioactive waste. I have brought you something. I have here a tile that's been covered in uranium-based paint. Uranium is a naturally occurring radioactive element. So this is in its natural state. Yeah? It's non-enriched, so it's safe to touch. And this is a beta and gamma radiation measurement tool. Let's see what happens if I bring these two together. Can you hear that? Okay, enough proof. So this is what uranium sounds like in its natural environment. However, when it's enriched, what you need to do to power nuclear power plants, this becomes dangerous to humans and the environment, and it needs to be stored in a safe place. Finding a suitable space for radioactive waste is challenging because half-lives of nuclides can last millions of years. And huge amounts of so-called low, medium, and high-level waste are generated during the process of nuclear energy production. Radioactive waste is a global issue that affects us all. Here you see in green countries that have nuclear power reactors currently operating. In yellow, you see countries that are currently constructing nuclear power reactors. Many more countries are currently investigating or preparing to use nuclear power solutions in their energy mix as an alternative energy source. How many of these 32 green countries do you think have a solution for a permanent radioactive waste repository? Who thinks all 32? Okay. Who thinks half of them? Who thinks one or less? Yeah. Exactly. Exactly, only one country has a permanent solution to store their radioactive waste. So how long do we want to store this waste for? Any ideas? 100 years? 1,000 years? Maybe 100,000 years? We need to store this waste for 1 million years required by German law. So how long is 1 million years? It's longer than humankind has existed on this earth since the development of Homo sapiens, roughly 200,000 years ago. So that's 5 times longer than the first human on earth has been existing for. So we're talking about real long-term storage. Let's have a look at what ideas exist. In the past, people have been thinking about launching via rockets and shuttle systems the waste into space, keeping it in orbit, or potentially storing it on the moon's surface. Alternatively, they have considered placing the heat-generating waste on top of large ice shields in the Antarctic or maybe Greenland to lower the waste by itself through heat through the ice sheet to the bottom. Alternatively, they have discussed sinking the waste in containers onto the seafloor, so into deep oceans, waiting for the container to corrode and slowly disperse the waste in the ocean. What do all these ideas and options have in common? They've been discarded. They've been considered too risky and sometimes too expensive. For example, a failed rocket launch would have fatal consequences for the retrievability of that waste. Climate change will impact the ice shield thickness in the future and its composition, making it unpredictable. And lowering or sinking it into the sea will mean a lack of control over these processes if we leave it to the ocean currents to decide where to accumulate and where to disperse the nuclear radioactive waste. In the meantime, the waste is stored in containers like these. They're about 5 to 6 meters high and are called Castor containers. They've been built for safe transport and temporary storage of highly radioactive waste. They have not been built for 1 million years to last. Instead, they have a license for use for about 40 years. Quick math shows that that's 0.0004% of the time. So a tiny fraction of the time period that we're looking for. Some scientists work on a daily basis with materials that are older than 1 million years. They're usually hundreds of millions of years old. Can you guess who? Geologists like me. Geologists propose deep geological storage for highly radioactive waste. So, what does deep geological storage mean? Everybody put on their hard hats and their safety overalls. And let's go down several hundreds of meters below the subsurface. Where can we find a deep geological storage? The best place to store radioactive waste is a place that isolates the nuclear waste from the environment. Isolation means no fluids can pass or reach this site, and that no fluids can neither leave that site. Contaminated fluids reaching groundwater reserves or the surface would be extremely harmful for humans and the environment. So what does the rock look at this depth like? On the left-hand side, you see crystalline rock. This is a type of granite, which you may be familiar with from your kitchen countertop. In the middle, we have rock salt, which you may know in its granulated form as table salt. And on the right-hand side, we have claystone. which is sometimes used as a powder to settle your makeup or as cat litter. Cat litter gives the clue why this material could be beneficial to be used in and as a repository site. Clay takes up fluids and combines with the surrounding material, swelling and sealing cavities off. I'm not going to go into the analogy with the cat toilet at this point. However, claystone also has a major disadvantage. When under heat, high heat, it becomes hard and brittle and start to form cracks. And emplaced radioactive waste is a heat-emitting source. And cracks mean that fluids can pass through this rock, through these cracks. How about rock salt? Rock salt becomes ductile, almost viscous and like fluid-like, under great pressure, like under several layers of soil and rock. So it infills cavities and again acts like a seal. However, as you know from your cooking experience, it's highly soluble. So you have a high risk of losing your rock once it comes in contact with fresh water. And last but not least, crystalline rock. It's a super dense material, so it lets no fluids go through it. However, because it's so dense, it's extremely brittle and tends to form cracks under pressure. And that again means, like you know, the potential to let contaminated fluids go through it. Finally, we have arrived in our deep geological repository, our only deep geological repository available at this point. It is located in crystalline rock, like you see here, and the nuclear waste is placed in cylindric containers into vertical boreholes inside a tunnel system. The waste is then isolated from one another through the help of claystone rock. The combination of approaches and solutions have proven to be the safest option for a deep geological repository. I'm calling on all of us to combine our forces and to put this agenda, this topic, on the agendas, national agendas and international agendas, together with our friends and colleagues, with industry, with research, with politicians, to build more deep geological repositories for high-level waste. This way, we can ensure the safe containment of radioactive waste and also make sure that all countries have access to a final storage solution. Let's join efforts, get active, and make 32 32. Thank you very much.